So, and the problem with a fraction, that is, if you see a square root in the denominator, you have to get rid of that square root. You have to do what we call rationalize that denominator. And the way we do that, again, we don't mind if there is in the numerator. If in the top there's a radical, that's not a problem. The problem is if there's a radical in the bottom, in the denominator. And it if it's just, if it would have been just the square root of 6, there was just one term there, then we would have multiplied by the square root of 6. But when we have two terms, which we see right here, because there's a minus, there's a plus or a minus between them, it means it's two terms. Then what we must do is multiply by what we call the conjugate of the denominator, which means you're going to multiply by the exact same binomial, except with the sign in the middle being the opposite sign. So my conjugate of 9 minus radical 6 is 9 plus radical 6. Now, of course, if I'm multiplying the denominator by 9 plus radical 6, I've got to multiply the numerator by that as well, because I don't want to change the value of the fraction. I'm just changing its format. Now, I always actually like to do the bottom first, because I know when I'm multiplying conjugates, it's really an easy process because I don't have to do the whole FOIL. I know the outer and the inner of the FOIL are going to cancel out. So all I have to do is the first, the 9 times 9, which is 81. And the seconds, the negative times the positive is negative. And square root of 6 times square root of 6, remember when you're multiplying a square by itself, it just gives you the number without the square root. So anytime you're multiplying the conjugates, what you're going to end up with is something without any square roots, and that's what we're looking for because we don't want a square root in our denominator. This is 81 minus 6, which if I correctly figure it out, it's 71. I can now combine them because there's no radical. So my denominator then would be rationalized. Let's see what happens when we get the numerator.
Professor, I got 36.
Anna, you have a question?
No, I said I got 36. The 9 times 4.
Okay.
I got
So
30.
there actually are two ways you could write it. You could just write it as 4 parentheses 9 plus radical 6 in parentheses. In other words, if you wrote your answer 4 times 9 plus radical 6 over 75, this would be perfectly correct because it's just given in what we call the factored form. We factored out, we have the 4 separate and the 9 plus radical 6 factored. That's one way of giving your answer. The other way is to actually use the distributive property and do 4 times 9, as Devonna said, which gave us 36. But don't forget to do the 4 times the radical 6 as well. And those you just write 4 radical 6 because you can't multiply them together. This is an outside number, doesn't have any radical. This is inside a radical. You just leave them separate and put the whole thing over 75. So either this answer or this answer would be considered correct and acceptable. Um, I don't know who this is. I see somebody trying to get into our I'm going to remove this person. Okay, there was somebody that was, I was unfamiliar. I just removed them. I'm not allowing anybody that I don't recognize to enter the class, the Zoom class. Okay, any questions about these now? So that is, so when they tell you to divide, it really means with the radical to rationalize the denominator, and you can get either this answer or this answer, and it is correct. Okay, so let's now look at this example. This is a solving of a radical equation. I'm sorry, Corey, what was your, I have just, you mean you wouldn't have removed them? I don't know who they are. It was a very strange. So if they're gonna wanna come in, they're gonna have to come in some other way. You're gonna have to put in their actual name. All right, so we have this radical equation. And we want to solve this radical equation. And the first thing we do is when we're solving a radical equation is that we try and get and see that what we have is that the radical, the square root, is all by itself. It's isolated. There's no number added to it on the outside. There's no number subtracted on the outside. There's nothing multiplied. We want the square root, the radical, to be all by itself, which it is. And then we do the opposite operation of taking the square root, which means to square it. We have to square it because we want to get rid of this square root. Now we know when we multiply the square root of 2x plus 8 by itself, that's what squaring means, it just gives you the 2x plus 8. The other side, the 4, is not inside a radical. So when I multiply by itself, I actually have to multiply. I have to do 4 times 4, and it gives me 16. And what ends up is that I get a regular algebraic equation. Sometimes it's a linear equation like this. Sometimes it comes out to be a quadratic equation. But what we just, this case, it's a simple equation. We're going to subtract 8 from both sides. This will give us 2x equals 16 minus 8, which is 8. And when I divide by 2, I get x equal to 4. I just have to go back on these radical equations. Once I get my answer, I have to check. I have to check because sometimes I get something called an extraneous root. I've done all my work correctly, but the answer didn't come out to be a valid answer. So I check my answer with x equals 4. I'm going to get the square root of 2 times 4 plus 8 equals 4. I'm just replacing the x with 4. And 2 times 4 is 8. 8 plus 8 is 16. So this becomes the square root of 16 equals 4. And that, of course, is true. So it checks. And therefore, my answer is x equals 4. So that's a review of the type of questions that we had covered on when did I cover them? On Tuesday. Somebody mentioned that they're still a little bit unsure about some of the examples that are going to be on the Delta quiz. Now, these type of examples are not. There aren't going to be any square root examples on the Delta quiz. The Delta quiz is specifically on fractions. Oh, several people have already done it and they've done very nicely on it. If you haven't taken it yet, don't forget that you have until tomorrow evening. I think you have until 11 p.m. tomorrow to complete it. Again, if you run into problems in the middle, I can always extend your time. If you send me an email, I can help you if you resolve any problems you may run into. I will, at the end of the period, spend the last half hour just doing a few of the types of examples that you're going to see on that quiz, just as a review. Now, those of you who've already taken the quiz can either, if you want, I won't mind if you leave at that point, it's fine. Or it certainly is going to be,
Professor,
we're coming up, I'll answer. We're coming up to the final pretty shortly, so it won't hurt us to have.
I'm sorry that I'm interrupting you, but the person who was trying to get on was Omar. His laptop is messed up and he's trying to get on with his brother's laptop. And he said they removed him and he's trying to get in.
I removed him.
So should I tell him just to go back on?
He should try and get back on. I removed him because it was a very strange
Yeah, it was him trying to get on through his brother's laptop.
Try to tell him to use his own name, and then I'll let him in. But if I'll see that, if he tries to get on again and I see that, I'll accept that.
Okay.
But tell him just to use his own name. Thanks a lot.
No problem.
Yeah, I'm hesitant to allow people using it's in when I don't know who they are because we've had problems. Okay, so I'm going to continue with our discussion of solving of radical equations. I want to do one step higher, a little bit more complicated example. And then I want to continue with some of the other materials that we might see in this chapter. So can I erase this now?
Yeah, go ahead.
Okay. So let's say I gave you a problem that looks like this. X plus 2 equals, no, let me rewrite this. The square root of x plus 2 minus 2 equals x. And suppose we want to solve this equation. Again, it's a radical equation. We have a square root in it, and we want to solve the equation. And we know that the first step that we usually do when we want to solve an equation is we want to get the radical all by itself, which means that this minus 2 out here has to go to the other side. So I'm going to bring 2 to both sides. I'm going to add 2 to both sides. So that I'm left with the square root of x plus 2 equals x plus 2. Now, what's different about this is the fact that on this side, I have not just a plain number, but I have a variable as well. But the method is going to be the same. We're going to want to get rid of the radical, and we're going to do that by squaring both sides, taking each side and multiplying it by itself. Now, when I multiply the square root of x plus 2 by itself, that's just going to give me x plus 2. That's the whole point. When you square something with a square root over it, All it does is it removes the square root. It looks complicated, but it's really easy to do. On the other side, there's no square root sign. So that I actually have to do the squaring. I actually have to multiply the x plus 2 by itself. I have to multiply x plus 2 times x plus 2. So again, this side, when I multiply it by itself, just gives me what's inside the radical. But this side that has no radical in it has to actually multiply it out. Okay, so now I've got an equation that has no radical, but it has to be solved. And the first thing I have to do, of course, is remove the parentheses. So I'm going to leave the x plus 2 over here alone. And over here, I'm going to use FOIL because I have two binomials. And they're not conjugate binomials, they actually are identical binomials. So I have to do the complete FOIL. X times x is x squared. I'm sorry. There. Okay, since you removed him, is not allowed him to sign with. He's getting pop-up saying you removed. But he used some strange. I removed him because it was a very strange. Can he try and?
I told him, he said he's gonna try to go on with his phone now because since you removed him the first time, it just keeps giving him pop-up saying, since you were removed from host, I can't let you back in.
Oh, okay. I should have done what Corey said, just ignore it. I'm sorry. As much as I know Zoom, this part of Zoom, I don't know. What happens when, I assumed it was somebody, I thought it was a prankster. It was just a very strange, he was using as a, oh, he's getting on, okay. Hi, Umar. Umar? I don't know whether he can hear me. Okay, well, let's continue. All right, so I'm trying to multiply this x plus 2 by the x plus 2.
Good morning, Professor. I'm here.
Yeah, question?
I said I'm here. I'm present.
Yeah, I saw April. I didn't take attention, but so I admitted you, yes. Okay, so x times x will give me x squared. I'm doing the whole FOIL, so I'm doing x times 2, the outer, which will give me 2x. And the inner is, again, another 2x. And last is I keep letting in the same exact people. Are people getting bumped off?
Good morning, Professor. Yes, I'm getting bumped off a lot.
Because I see, I admitted you, like this is the third time. I don't know.
Yeah.
I don't
I'm
know
getting
why.
bumped off a lot.
I don't know why. Sorry. Okay, and finally, we're doing 2 times 2, which is 4. Okay. So if I combine all the like terms over here, this stays the x plus 2. And this becomes x squared. 2x and 2x is 4x plus 4. And what ended up as looking like a regular radical equation actually turns out to give me a quadratic equation. And I know when I have quadratic equations, I want to get them equal to 0. And it just makes much more sense to bring everything to the right side because there's where my x squared is. I'm going to subtract x from both sides. I'm going to subtract 2 from both sides. So that my quadratic equation, becomes 0 over here, and this is x squared, and 4x minus x is 3x, and 4 minus 2 is 2. So I now have to I'm sorry Umar, I'm sorry you had that problem. It came up as a very strange name, and so I just said, I thought somebody was playing games, and I just,
Yeah, I forgot to change it. I'm sorry.
I'm sorry about that.
Yeah, it's all right.
Okay, thanks.
Mm-hmm.
Okay, so we have this x squared plus 3x plus 2 that we want to factor. And we know that the AC is 2. This is 1 times 2. So we're looking for two numbers that multiply to 2, but when we add them, they're going to add up to 3. And obviously that's 1 and 2. So I'm going to break up the x squared into 2x and x, because that's my 3x, plus 2. So I can do my factoring by grouping. In the first group, I have x times x plus 2. In the second group, there's no common factor, so I just do a plus 1 and put the x plus 2. So that gives me, after I factor x plus 2 in one parentheses and x plus 1 in our other parentheses. Now this is equal to the 0. So I'm going to have to set each of these equal to 0. X plus 2 equals to 0. And x plus 1 equals to 0. And this gives me one answer is x equals -2. And the other answer it gives me is x equals -1. And now that I've done that, I must check. Because after all this work, it's possible that one of these answers or both of these answers don't work. So let's check first with x equals -2. Go back to your original equation, and we have -2 plus 2 minus 2 equals -2. Well, let's see if that works. -2 plus 2 is 0, so this is the square root of 0 minus 2 equals -2. And the square root of 0, of course, is 0. So 0 minus 2, that checks. That is a good answer. Let's see what happens when we try x equals -1. So I have the square root of -1 plus 2 minus 2 equals -1. And -1 plus 2 is 1. So I get the square root of 1 minus 2 equals -1. And actually, the square root of 1 is 1. So 1 minus 2 equals -1. That's also checks. Both answers check. So in this case, there were two answers to the question, -2 and -1. So what do we learn from this? When we have a radical equation and it's the whole point of that radical equation is to get the radical by itself and then square both sides. Sometimes it comes out to be a very complicated equation. This was a very long question. Okay. Does anybody still want it on the board?
Just need one more minute.
Sure.
Professor, what is this called? Because every time we're doing a problem, I always put the name of the problem.
It's solving radical equations. I should write it down. I sort of always say it, but I probably say it so quickly you don't hear it. This is a continuation of what we're doing, which is solving radical equations.
Thank you.
Okay. Now I want to show you what I think you should do if you would have some, see the one that we did before that only had a plain number on this side, if you only have a plain number over here, when you square it, it's not a problem. It just gives you a number. The problem arises, what makes it much more complicated is when what you have outside of radical is also a variable. So I'm going to show you what you should do if you get this kind of question on a final exam. Okay, but tell me, are you ready to let me, can I erase it? Anybody? Okay, Jennifer told me yes, so I assume most people have it now. Okay, I'm going to an example that was on a previous final. Here's the example. They want you to solve x equals the square root of x plus 13 plus 7. And it's a multiple choice question, and here are your choices. A, 3 and 12. B, 3. C, 12. D, -9. Okay, remember, it's a radical equation, so and it's got this variable on the outside, which tells me it's going to be a long question. And after I do all the work, I'm going to have to check my answers. Anytime I have a problem that requires me to check my answers, it makes most sense when I have a multiple choice problem just to do the check. In other words, take each of these values. Now, if you think about them, it's not really so many. One answer is 3 and 12. So you can check the number 3. You can check the number 12. Notice that'll take care of choices B and C as well. The only other thing you'll have to check is -9. Now, you might even not have to check -9. If you get one of these answers being correct, remember, they have to put down all the answers. If one of the answers is, let's say, 3, then you would know, and 12 doesn't work. You know your answer would have to be B. You wouldn't even have to get to 9. So here's what we do. We check. So the first thing I see is x equals 3. Because the first answer is giving me 2 choices. So here's when I check, I'm replacing x with 3. So I get 3 equals the square root of 3 plus 13 plus 7. Let's see if that works. So I have to simplify this. The 3 plus the 13 gives me 16. And the square root of 16 is 4. So this ends up being 3 equals 4 plus 7. Does that make sense? Obviously not. 4 plus 7 is 11. 3 and 11 don't match. So x equals 3 right away turns out to be a wrong answer, which means I can right away throw out choice B and choice A and choice B, because they include 3 as an answer. And we saw 3 didn't work. Okay, the next thing I see is 12. Let's try 12. So I'm going to check with x equals 12. Again, I'm going to put 12 in place of my x. So it's 12 equals 12 plus 13 square root plus 7. Now 12 plus 13 is 25. So this is the square root of 25. So we get 12 equals the square root of 25 plus 7. Now I know the square root of 25 is 5. And that last statement gives me 12 equals 5 plus 7. And that is actually true because 5 plus 7 is equal to 12. This works, which means I now know my answer is choice C. Obviously, I'm not even going to try the -9 because I know I came up with the right answer. If this would have been 12 and -9, if it would have included 12 as an answer, I might have had to then try the -9. But in this case, the only possibility of a right answer is 12. And notice, if I would have done all the work to work it out, and then I still would have had to do this check. So it's not like I'm doing extra work and doing the check. I'd have to do the check anyhow. So now this only works because this is a multiple choice question. They're giving you just a few choices. So it makes sense just to try and see. And it's a perfectly valid way to solve this problem. Any questions about that?
Professor, how would you work this out on your calculator?
How would you solve it on your calculator?
Yeah,
Your calculator
it
doesn't.
cannot be.
You mean how to put this into, like, your calculator?
Like the x square root x plus 13 plus 7.
Your calculator does not solve equations. What you could do is you could do the square root. Now, in your calculator, when you use the square root, you usually have to put in a parentheses. You would have put in the 12 plus 13 and close the parentheses. So that means you're not going any further on the square root, and then plus the 7. And if you do that and you press equal, it should give you 12. I don't know if that's what your question is.
Yeah, that was what I was asking.
Okay. All right. Now, let's go back and think about when we first started talking about radicals, when we first started talking about square roots. One of the things we said you can have inside a square root is a negative number. In other words, you can have the square root of -25. When you're dealing with only real numbers, the numbers that we deal with on a general basis, then you can't have a negative inside a square root. Why? Because when you ask for the square root of something like -25, you're looking for a number that when you multiply it by itself, it's going to give you this -25. And we know, and when we're dealing with regular numbers, our numbers are either going to be positive or negative. And if you multiply a positive times a positive, the answer is going to be positive. It won't give you -25. And when you multiply a negative by a negative, it'll also give you a positive number. You will never be able to get a number multiplied by itself that will end up being negative. That we started our discussion that way, and we said we cannot take. So, and if you try it on your regular calculator and you put in something like the square root of -25, it'll probably give you an error message. An error message means you're trying to do something that's not possible to do. That's because we are talking about the set of real numbers. Okay, I want to go a step further and talk about a new set of numbers. This new set of numbers is called the complex number system. In this new number system, we add one additional number that we never had before. Now, since it's a new number, we have to give it a new symbol. And we can't use a symbol that we've already used for numbers, so we're going to use this symbol. It can be written this way or this way. It's a lowercase I. I'm going to use this format. Notice I'm going to be very careful not only to, I'm not going to write it the I like this, and I'll tell you why I'm not going to write it like this, because if you look to, if you don't see, you might not see that dot on top and it'll look like a 1. This is not a 1, this is a new number. It's called the number I. And this is the value of I. I is given the value the square root of -1. The new number. We never had something that you could do the square root of a negative number. It's a new number. If ever I come across the square root of -1, the answer only in the complex number system is going to be I. In the regular number system, the real number system, the number system that we use except for this particular chapter now, that in the real number system, this does not exist. That's why don't we use the term I for it? Because sometimes it's called the imaginary number. It's not that it's a figment of my imagination. It's just to tell you this number is not part of that regular number system that we call the real number system. Something that's not real, let's call it imaginary. Instead of just saying it's not real, we'll just say it's imaginary. And you'll know whenever I talk about this imaginary number, you'll know that I'm talking about the system of numbers that allows you to use the number I. In the complex numbers, you can use all the regular numbers plus I. In the real number system, you can just use the real numbers. You can't use I. Now, how does this help me if I want to do the square root of -25, for example? Well, all the rules that apply to regular numbers, all the rules of algebra apply in this complex number system as well. So I could break this up into the square root of 25 and the square root of -1, because 25 times -1 is -25. And now, since this is a square root of a regular number without any negative, square root of 25 is 5. And the square root of -1 is this new number, which we call I. So anytime I have a square root of a negative number, all I'm going to do is I'm going to break it up into a positive number times the square root of -1. And where I have the square root of -1, I'm going to use this new unit called I. Now, when I want to work with numbers, I cannot work with square roots of negative numbers. What I can do is I can convert them, if I'm using the complex number system, I can convert them to I's. So if I have something, let's say the square root of -50, I could break that up into the square root of 50 and the square root of -1. And of course, the square root of -1, remember, that's what we're calling our I. And the square root of 50, I could actually simplify now, because I know how to, this is now a regular number. I can break that up into 25 and 2. So in the end, when I want to simplify this thing, the square root of 25 is going to be 5. The square root of -2 is going to stay square root of -2 because it's not a rational number. It doesn't have a square root. And the square root of -1 is going to be I. So this is going to be simplified into the product, into multiplying 5 times radical 2 times I.
Perfect.
Very often when we write this, we put the I next to the 5. We like to have, when we have 3 things multiplied, if there's a radical, we like to have that at the end. So a better way of writing this is 5I times square root of 2. That's just because if you're not careful, you might make that line too long and it'll look like the I is in the square root.
So Professor, we have to write about the I?
Yes, you have to write the I because if you don't write the I, what happened to the negative?
Oh,
The negative,
see.
so here's what it is. The negative inside the square root translates to an I without a square root. If I have something like the square root of -100, then that's really 100 and -1. The square root of 100 is 10. So the square root of -1 is I. I must put in that I. Whenever I have
wait,
a
so,
negative inside a radical, you must
Mhm.
have I.
okay.
Tracy, what's your question now? Did I answer your question?
Yes, Professor.
Good. Jennifer? Was it Jennifer that was asking a question also? Let me
Yeah, I
look.
was just gonna ask that when do you use the I when there's a negative, right?
Yes, but
So
notice
that
where is
-50 became a positive
use the
50.
I when the negative is inside the radical. If I had something like this, a minus in front of the radical, it's not inside the radical, it's outside the radical, then that just stays a minus, and this just becomes -10. 10I is not the same as -10. -10 is what we call a real number. But any number that's next to an I is this imaginary number. It's a part of the complex numbers. Do you understand the difference?
I need to see this another problem again.
Okay, let's do some more problems. Suppose I gave you a problem that looks like this. I want you to combine all the like terms. The square root of 36 minus the square root of 81. Wait, let's do this. The square root of -81 plus the square root of 100 minus 3i. Let's say I give you this whole long contraction here. Square root of 36 minus square root of -81 plus the square root of 100 minus 3i. And I want you to simplify this as much as you can. In order to do that, I want to take all my radicals and simplify them as much as I can. Well, the square root of 36, that's easy to simplify. What is the square root of 36? It's just plain 6. Similarly, I'm skipping this for a second. What's the square root of 100? That's
10.
easy. How much is this? That's just
10.
10. Okay, this 3i, we don't have to worry about it, doesn't have any radical. What about the square root of negative 81? What's the problem with that? The problem is this negative here. This negative is telling me that I'm going to have a complex number. I have a square root, I break it up into and negative 1. These are both inside radicals. Everybody okay? Am I okay? Because I got this up. Everybody following
Yeah.
me?
Yes.
Okay. Now the square root of 81, the square root of 81 is just plain 9
Is
because
9.
that's a number now. And the square root of negative 1, wherever I see that square root of negative 1, I replace that with an I. So this becomes minus 9i. I break up the anytime I see a negative inside a radical, I break it up into the positive number times negative 1. The square root of the negative 1 becomes I. The square root of 81 in this case becomes 9. Now, if I look at what I have over here, I want to combine all the like terms. And it works just like it does with regular numbers. This I is like an X. I can't add the 6 and the negative 9i. They're not like terms. But I can add the 6 with a 10. That'll give me 16. And I can add the negative 9i minus and the negative 3i. That becomes negative 12i. This is the type of numbers that you see. They're called numbers in A plus BI form. Those are the type of numbers you often see in the complex number, where you have a combination of real number, a number that doesn't have an I, with a number that does have an I. You cannot combine these because they're not like terms. You have to leave it 16 minus 12i.
Professor,
Yes.
I'm confused. Where did you get the 16 and the negative 12? The minus 12?
Okay. Let me, I'm gonna go back. I'm gonna erase this and go back. Okay, were you okay with this part?
Yeah.
Okay, the square root of 36 became 6. The square root of negative 81, that became the 9i. The easy way to do it is just take the square root of this number, which is the 9, and the negative inside just makes it an I on the outside. The square root of 100 was 10, and this was negative 3i. So what are my like terms? Well, first of all, the 6, the only thing that's like the 6 is the 10 because they don't have anything next to it. They have no variable next to it. They have no letter next to it. So I can combine the 6 and the 10. That gives me my 16. Then I go to the negative, so that takes care of this and this. Now I have the next thing I see is negative 9i. The negative 9i, well, there's a negative 3i as well. How do I add a negative 9i and a negative 3i? It's basically, yes, exactly, Corey. It's just combining like terms. Negative 9 and negative 3 is negative 12, so that becomes negative 12i. Don't try to add these two together. This has a variable, a letter next to it. It's not a variable. I stands for a specific number. It's not like an X. An X can have a lot of different values. When you see an I, you know right away it means it's square root of negative 1. But basically, the rule is exactly the same. Does that answer your question? Who
Yes.
who asked me the question? Katira?
Mm-hmm. Yeah.
Okay, you okay now, how I got it?
Yeah.
Okay, let's see. I want to do one more thing with this, and then I'm going to give you a couple of problems to try on your own. When we're adding and subtracting, as we did over here, once we've simplified, we just combine the like terms. But what happens when we try to multiply? Let's say I have, let's start with something like this. 6i times 5i. Now remember, whenever I see a square root with a negative in it, I know I first have to simplify it to its form in I. I know it's going to have an I. That's the first step. Now, most of the time, the questions you're going to give will already have the i's in them. But if you see something like the square root of -1, first combine, make sure that you write it in terms of I. Don't work with square roots of negatives. You just, now, let's say I want to multiply this complex number, 6i, times the complex number 5i. I know they're complex numbers because they have i's in them. Okay. Well, guess what? I'm going to use my rules of algebra. 6i times 5, I'll just multiply the 6 times the 5, which will give me 30. And the I times the I, which gives me I squared. As simple as that. Regular algebra. The only thing is I want to examine what does it mean when we have I squared. What happens when I want to multiply I times I? That's I squared. Well, if you think about it, it means that you're multiplying. Remember what I stands for. It's not -1, it's the square root of -1. So I am multiplying the square root of -1 times the square root of -1. And what happens when I multiply a square root by itself? What happens when I multiply this?
Get back the square root.
You just get that number, right? It gets rid of the square root. In other words, I times I, when I multiply the I by itself, it gives me -1. I squared, this is the most important thing to remember. I itself is not a real number. It's a complex number. But I squared is just -1. I squared is a real number because it's a -1 without the radical. Anytime I multiply something with a radical by itself, it gives me what's inside the radical. So if I get this answer, 30i squared, anytime I see an I squared, I'm going to replace that I squared by -1. If I see I alone, I'll leave it I. But if I see I squared, I will know it's equal to -1. I'll simplify it by replacing it by -1. And notice then I'll have 30 times -1. I'm not subtracting, I'm multiplying. 30 times -1, so my answer would be -30. So the real answer to 6i times 5i is -30. That's the most important thing for you to remember, that when you when you're multiplying, it happens during multiplication, that when you multiply numbers that have i's in them, then very often you're going to come up with an I squared. And whenever you see that I squared, then you have to replace the I squared by -1. And the final answer, yes, Jennifer, is -30. If you can get an answer that doesn't have an I in it, sometimes it's not possible to get rid of the I, but if you can get rid of the I, you're going to want to do it. Okay, so let me show you another example, and then I'm going to give you something to try on your own. Suppose I gave you this problem. I want to multiply 2 plus 7i by 5 minus 3i. This is, remember, this is a plus bi form. This is a complex number, and we're multiplying by another complex number. But think about it. These are binomials. I can't combine these two because this doesn't have an I and this does. It's just a binomial times a binomial. How do we multiply binomials? Well, we've been doing binomials all along by using FOIL. So let's use FOIL. First, 2 times 5 is 10. Outer, 2 times negative 3i is negative 6i. It's doing this just like regular algebra. You would know how to do this if it's an x.
Professor, not touching you with this though. We're doing the FOIL, right?
What? I'm sorry.
We're doing the FOIL.
We're doing FOIL. First, outer, inner, last. First, 2 times 5, outer. 2 times negative 3i. Inner,
Okay.
7i times 5. That's 35i. And last, 7i times negative 3i, which is negative 21i squared. Be careful, when you have an I times an I, you're getting an I squared. And as soon as I see I squared, before I do anything else, I remember my rule. I squared has a value. What did we say the value of I squared is equal to?
-1.
-1.
It's -1. So actually, this becomes a negative 21 times a -1. We're multiplying this, which becomes a plus 21. And now I can combine the like terms. That's the 10 and the 21, because those don't have any i's anymore. Give me 31. And then negative 6i plus the 35i. Well, negative 6 plus 35 is 29. So that's plus 29i. And I can't make this any simpler because these are not like terms. This has an I, this doesn't. If you notice, it's an A plus BI form. It's a complex number. So really, you know,
How did you get the 31?
I added, remember this negative 21 times -1 became a positive 21.
Oh, okay. Yeah.
Positive 21, I added with this positive 10 because those are the numbers that don't have any i's. That's where I got my 31.
Is
Okay,
that
now I got from combining these two. You ready
Is
to
that-
try something on your own?
is that negative 21 I squared?
I can try.
This was, let's go back. This was a positive 7i times a negative 3i. So the 7 times a negative 3 gave me negative 21. And the I times the I gave me I squared. Now remember, the I squared itself is equal to -1. So I have a negative 21 times a -1. Remember, these two get multiplied. That's where it became a positive 21. Don't forget the I squared itself is equal to -1, and you have to multiply whatever it is by -1. Okay, here's one for you to try. While you're trying this, I'm going to be taking attendance. 9 minus 2i times 4 minus 9i. Okay. Zia,
Yes, Professor.
good morning.
Good morning, Professor.
Good morning. Nashia Allen. Annabelcus Baez. Emma Benedict. Messiah Bethia. Corey Brown. Corey, were you here on
Here.
Tuesday?
No, I wasn't.
Okay, so I have that correct. April, you're here, I know. Khadija, you're here. Umar, I know you're here. Sorry about the whole mix-up. Yakima Ellison. Cheryl, you're here. Stacia, you're here. Denisha. Devana, you're here.
Present.
Natalie. Is Natalie here?
I'm here.
Yeah, good. Erica, I know you're here.
Yeah,
Jonathan. Anybody know what happened with Jonathan?
I'm here, Professor.
Oh, wait, Erica, I know you're here.
Sorry, I'm
What-
sorry.
John,
Jonathan had a doctor's appointment this morning.
okay. I know he's always here. That's why I'm surprised he's not. Luke is here, right? I let Luke in.
Yeah, I'm here.
Layla, you're here. I know I let you in. Ashley, if you weren't, you're here now. If you're not here now, you were before. Kachira,
Good morning.
good morning. Jennifer,
Right here.
yep. And Rachel, I know I let you in, and Gloria. I don't think. Okay. So let's see if we could now do this example. Remember, we're multiplying two binomials that have i's in them. Again, don't ever think that if you ever see this I, this little script I, in any math situation, it's used exclusively for this complex number, the square root of -1. It isn't used, we never use it like an x is just a variable, that it could take different values. Layla, I know I saw you were here. So when I have these two binomials that I want to multiply, I'm going to use FOIL. So again, 9 times 4, that's first, is 36. Oh, outer, 9 times -9i. Well, that's -81i. Don't forget there's an I there attached to this. And it's a +9 times a -9, so that's our negative 81i. Enter. -2i times +4 is -8i. And last is -2i times -9i. So -2 times -9 is +18.
18
And
I squared.
is I squared. And don't forget,
We have
if you're gonna ask me what's the most common error people are gonna make, they're gonna do I times I and come up with I. I times I is I squared. Just like X times X is X squared, I times I is I squared. And anytime I see that I squared, I put a -1 in place of it. So the first thing I'm going to do is multiply the 18 times the -1. That will give me my
-18.
These two things I can't do anything with because they don't have I squared, they just have I's. So now I combine the like terms. First of all, the numbers that don't have any I's are the 36 minus 18, which gives me 18. And then the I terms are negative 81i and negative 8i, which gives me negative 89i. How many people got that answer?
Professor, at the end, I got, at the first time I did, I got 54 because I added the 36 and I didn't see that it was a positive. So I just put positive 18 and added 36 and 18, and that's how I got 54. But now I understand. I get it.
What you're
Yeah, I
telling
got 54 at first as
what
well.
you're telling me is that you're making the most common mistakes, which is making mistakes with signs, with positive and negative signs. Just be careful. Now, some of your calculators might even have the ability, if you put in some of them, and I don't even know which ones are, but some of them do have the ability to do I's. And then you could just stick it into your calculator. But I always like to do it by hand anyhow. It's not hard, it's just carefulness that you need here. It isn't hard. Okay, I want to do one more type of question because that will finish up this chapter. But when we start tomorrow, that's exactly where I'm going to start. What do I want to do? What if I gave you a question that looks like this? Suppose I gave you a division example. Suppose I said divide. 3 over 5 minus 2i. If I gave you a division that has, we just did adding, subtracting, and multiplying. What happens if I ask you to divide? In other words, what if I give you a fraction that has an I in it? And specifically where the I is in the denominator, in the bottom. Well, really, this question is not just divide. This question is really rationalize the denominator. We just did that yesterday, Tuesday. We learned how to rationalize the denominator because we said when we have something with a radical, with a square root, we don't want to leave it in the final step with it in the denominator. Same thing over here. This I is really an irrational number. It's like the square root of it's a square root of a -1. It's a radical. We don't want to leave radicals in the denominator. So we somehow have to rationalize this denominator. And I'm going to use the same rules I did in rationalizing the denominator with any square root. I multiplied by the conjugate. These are 2 terms. My denominator has 2 terms. I multiplied by the conjugate of 5 minus 2i, which is 5 plus 2i. Just like I did with regular radicals, with regular square roots, I'm doing the same thing over here. Now, of course, whatever I multiply the denominator by, I've got to multiply the numerator by that as well. And I'm just going to use my regular rules. Again, I'm going to do the denominators first because they're conjugates. I know when I'm multiplying conjugates, which these are because they're identical binomials, but one has a minus and one has a plus. I don't have to do the whole FOIL. I can just do the first 5 times 5, which is 25. And the last, negative 2i times positive 2i, which is negative 4i. I squared. Don't forget that I times I gives me I squared. And again, I see that I squared, I know I have to put a -1 in place of it. So this actually becomes 25 plus 4, because -4 times -1 is positive, which is 29. We know whenever we multiply conjugates with radicals, we end up with a regular rational number, a regular number without any i's, without any square roots. In other words, my final answer is going to be 29 on the bottom. And the top, I have to multiply the 3 times the 5 plus 2i. Now 3, I'm just going to use distributive property. 3 times 5 is 15. And 3 times 2i is 6i. So my answer for this problem comes out to be 15 plus 6i all over 29. Just as an aside, this is a perfectly valid way to leave the answer, but sometimes what they do in these cases when you have an I is instead of putting it as 2 terms over 1, it gets separated and they put the 15 over the 29 separately with the 6i over 29 separately. You just put each one of them separately over 29. Very often the answer is given because this looks more like A plus BI 4. But actually, either one of these answers is correct. And you do that whenever you have a binomial in your denominator that has either a square root or an I, which is really a square root of -1. And we just multiply by the conjugate. Okay, so this is where we're going to do some more of these tomorrow. And
Okay, Professor, wait 1 second. So the bottom part, we just do the FOIL method and we multiply across, and then we do the same with the top. And then that's how you got 15 plus 6i over 29. I just want to make sure that that's correct.
Right.
Okay.
And again, either write it 15 plus 6i, the whole thing over 29, or put each of them separately over 29, 15 over 29 and 6i over 29.
And this formula is only when it's dividing.
This is when it's called dividing or rationalizing the denominator.
Okay, thank you.
Whenever you see a fraction with an I in the bottom or a square root in the bottom, this is what you're going to do. Any other questions? Okay, so according to me, we have 20 minutes left. And was it Ashley who asked me? Somebody asked me to to do some problems that have to do with what's on the quiz. Don't forget, you have till tomorrow night to do the quiz. I think I assigned an hour and a half. You don't need an hour and a half to do the quiz, but that's what I gave it. So make sure you're finished with the quiz by 11 o'clock tomorrow night. If you run into problems, you can always do it later. You can, how many questions? 10. There usually are on these Delta math tests. I try to give 10 questions. And if you run into any problems, just email me now and I can reset it or do whatever you want. But that is the initial thing. I just want to go over 2 or 3 different types of problems as a reminder. Again, that's on chapter 5. What we've been doing now is chapter 6. So that test is on chapter 5, which has to do with fractions. So let's look at some of the types of questions you might be encountered. You might have something like this. suppose I gave you x squared minus 1 over 9x, divide by x squared plus 7x minus 8 over 4x. Okay, in order to make the best use of the time, instead of giving you time to do these, I'm just going to go through them as a reminder as to how to do these type of problems. When you have a division problem with fractions, the first thing you want to do is change that division into a multiplication by taking the reciprocal, flipping the second fraction. Not only that, and then you're going to have a multiplication problem. Not only that, what you're going to want to do is also have everything factored. You're going to want to be able to cancel things out, and you can only cancel out factored examples. So I'm going to factor it as I do the reciprocal. So the x squared minus 1 is the difference of squares. That factors to x plus 1 and x minus 1. That's our difference of squares. The 9x, I just leave 9x because there's nothing to factor. It's only 9 times x. It's already in its factored form. Times, and remember I'm flipping this, so what's going to go on top is the 4x. And I have to factor the x squared plus 7x minus 8. So I'm going to do the factoring over here, and then I'm going to transfer it over here. So how do we factor x squared plus 7x minus 8? Well, obviously our AC is -8. So I have to find two numbers that when I multiply them will give me 8, but when I subtract them will give me 7. Obviously those numbers are 8 and 1. And since this is a positive of 7x, I'm going to write this as positive 8x and minus 1x minus 8. And here my common factor is x times x plus 8. And here my common factor is just -1. And that also gives me x plus 8. So that this gives me x plus 8 and x minus 1. Okay, so now I have things pretty much in the setup that I want. I don't have a division anymore. I flipped it so I have a multiplication. And everything, remember with multiplication and division, you have to factor everything, both tops and bottoms. Okay, now I'm going to erase this so I just have the room because we already did this. And what I'm going to do is I'm going to go across my example and see what I can cancel out. So there's an x plus 1 first. Remember, I deal with all the entire factor. There's no x plus 1 on the bottom. Do not make the mistake. X plus 1 doesn't cancel with x minus 1. They have to be identical. But here the x minus 1 can cancel with the x minus 1. Remember, when it comes to binomials, they have to be identical. The only change that you can have is if the order is switched. Here they're both in the same order, but not the sign, just the order. Then I go to the 4x. Now remember, with monomials, the number and the letter are separate. So this is a 4 times x, and this is a 9 times x. So the x's I can cancel out. I'll be just left with a 4 over here and a 9 here. The x canceled out. And now nothing else is left to cancel out. So my top becomes x plus 1 times 4. I'm just writing them next to each other. And the bottom is 9 and x plus 8. Now, usually when you have a binomial and a monomial, or just a number, you usually put that in front. So it's probably better to write a 4 parentheses x plus 1 over 9 parentheses x plus 8. There's nothing wrong with putting the 4 second, but it's just common practice to put the number that stands alone first. You could also have used a distributive property, but it's not necessary. And you would put it in your in your delta math, you would use you would put in 4 parentheses x plus 1, and then you press the slash button, it'll change it into a fraction. And then you'll put in the 9 and the x plus 8. Otherwise, if you don't have any parentheses, or you don't have any, put it in a parentheses. You really want the numerator in a parentheses and the denominator in a parentheses. Okay, so that's one type of problem you might see on the delta math. It's either a multiplication or a division. Again, you have to know how to factor, and because these problems are a bit on the harder side, I gave you 3 chances to do each problem. If you do it by 3 chances, if you've done it correctly, you're going to get 100% correct on the problem. Again, if you do the quiz and you're not happy with it, you can also ask me to reset it, and I can reset your examples. Okay, so now let's look at another type of a problem. Suppose I gave you this problem. 1 over 7x minus 3 over 4x. This is a subtraction. And when you're subtracting fractions, what you want to do is you want to make sure that you have a common denominator. And I'm going to do this one has as the denominator single terms, and then I'm going to do one that has polynomials or multiple terms in the denominator. When you're looking for a common denominator of monomials, you take the numbers separately and the letters separately. So you first think, what number will both 4 and 7 go into? And hint, if you can't think of any number, just multiply the 2 numbers together. 4 times 7 is 28. 28 will certainly work. 7 divides into 28. And 4 divides into 28. When it comes to the variables, look at all your variables and pick the one with the highest exponent. Well, this has an exponent of 1, and this also has an exponent of 1. So obviously my highest exponent is 1. My common denominator is 28x. So when I have monomials, I look at first the numbers, the coefficients, and then I look at the variables, the letters. Now I have to think what to do to the numerator. So I divide the 7x, the original denominator, into the new denominator. 7 into 28 is 4. The x cancels into the x. I have left with 4. 7x into 28x is plain 4. I take the 4 and multiply it by the numerator. 4 times 1 is 4. Do the same thing over here. 4x into 28x. The 4 into the 28 is 7. The x cancels out. I'm left with 7. I take the 7 and multiply it by the 3. That gives me 21. And finally, when I have my common denominator, I just combine the numerators. Now it's 4 minus 21, depending on whether the sign is plus or minus. 4 minus 21 is negative 17. So my answer becomes negative 17 over 28x. So again, to add or subtract fractions, I need a common denominator. Once I have a common denominator, I just work with the numerators and put the answer. Don't forget, you can't ignore the denominator when you're adding and subtracting. You must put it over the common denominator. When it comes to solving an equation, you can ignore the denominator, but not when it just says combine or add or subtract, then you have to put the common denominator in the bottom. Okay, let's look if we have if we have to combine something where the denominators are polynomials. So let's erase this. I think I'll just do that one more question. Suppose I gave you this, 5 over x plus 4 minus 7 over x squared minus 16. Suppose I wanted to combine these two fractions. Again, I need a common denominator. When it comes to finding a common denominator with polynomials, with more than one term, the first thing I have to do is factor my denominators. Now the x plus 4 can't be factored any further, but the x squared minus 16 can be factored to x plus 4 and x minus 4. And then to find what my common denominator is, I'm just going to look at it. I'm going to take everything from my first fraction, which is the x plus 4. And then I'm going to go to the next fraction. I already have the x plus 4, so I don't have to count that again. But I have to count the x minus 4 because I haven't written down the x minus 4. In other words, the x plus 4 only has to be written once. So my common denominator comes out to be the x plus 4 together with the x minus 4. Again, look at your denominators. Check off all the different factors you see. I see an x plus 4 and an x minus 4. Again, I don't check this again because I already have it checked. And therefore, my common denominator is x plus 4 and x minus 4. Then when it becomes time to see what to do to the numerator, compare your original denominator with your new denominator. So I have the x plus 4 here. That I already have. I'm comparing it. So what I don't have over here that I added is x minus 4. That's what I have to multiply the top by. X minus 4 times 5.
What if I multiplied x plus 5 times 5?
X plus 5? I only want to multiply by what wasn't there before. If I combine the x, I look at just the denominators. See this x plus 4? Over here I now have an x plus 4 and an x minus 4. The new guy in town is the x minus 4. That's what I've got to multiply by. Okay?
Yeah.
Now I go to the second thing. Second fraction. The x plus 4 is already there. The x minus 4 is already there. I don't have to multiply by anything because I haven't, this is the original denominator and the new denominator is identical. So I just leave this 7. That's why I like to put one right underneath the other because it's easy to compare. Compare what you originally had with what you're changing it to. And anything that's new that wasn't there before, that's what you multiply the top by. Now I actually have to multiply it out. The 5 times x minus 4 using the distributive property is 5x minus 20. And now I have a minus 7. And this all goes over my x plus 4 and then my x minus 4. And I combine the like terms and it becomes 5x. And negative 20 and negative 7 is minus 27. And that's x over x plus 4 and x minus 4. There's nothing, I can't factor the top, so there's nothing to cancel out. This is your final answer. It's a lot more work when you have polynomials. Again, just be careful. Okay, any question?
Professor, could you go over that one more time, please?
Sure. Want me to start from the, you want me to erase it and start from the beginning or just?
Yeah, you could erase it and start from the beginning.
All right, step 1. Factor your denominators. Remember, when you're multiplying and dividing, you factor both the top and the bottom. But when you're adding or subtracting, you just factor the denominators. You just break up the denominators. And this denominator stays x plus 4, and this x squared minus 16 becomes x plus 4 and x minus 4. And now this is how you pick out your common denominator. Start with your first factor. Your first denominator. Take everything that's there, which is x plus 4. Then go on to your next denominator. The x plus 4 has a check mark with it already, so I don't need it. So I'm not writing it, I'm not putting a check mark there because it's already checked here. But the x minus 4 is not checked, so let's put a check mark there. Here's my common denominator. X plus 4 and x minus 4. The two things I have checked. Okay, now let's see what we have to do to the numerators. That's why, look at, I rewrite each fraction right under where it was originally so that I can compare what I originally had to what I'm changing it to. Now, if I look at this, my original denominator had the x plus 4. What it doesn't have is the x minus 4. This was not here originally. That x minus 4 is what I have to multiply the 5 by. And I could actually either put it in parentheses or just multiply. But if I'm multiplying, don't forget to use the distributive property. 5 times x is 5x. 5 times -4 is -20. You could either write it with a 5 parentheses x minus 4, or you could actually multiply it out, because you really, in the end, don't want those parentheses. Now you go to your next fraction. The x plus 4 is there, the x minus 4 is there. There's nothing new here that wasn't here originally. I didn't change that denominator at all, so I'm not changing the numerator. I'm leaving it the 7. And now I'm gonna combine all the like terms, which is 5x minus 20 and minus 7. So the like terms are the -20 and the -7. That gives me the 5x minus the 27. And that all goes over the x plus 4 and the x minus 4. Was that better for you, Stacia?
Thank you.
What? I can't, I'm losing.
Thank you.
Okay, I think we're gonna stop right here. First of all, I'm having trouble with my internet. I see it's not so clear anymore. Again, if you still have questions, either email me your questions and I'll try to deal with them by email, or I will be on by 9:30 tomorrow, probably even earlier, but by 9:30, if you have questions, you can ask me then. Any questions you want, you can ask me. Okay, and I will see you tomorrow at 10 o'clock.
All right, bye.
Have a good day.
Professor.
Well, have a good day.